Okay, determine the value. Log 9, log 327. Okay, so I'm going to just do this first. We have to work on that first. What is your brain thinking? What's the base? 3 to the something. That's what we're trying to figure out. Gets me to 27. So this is 3. So that's a 3. So 3 cubed is 27. 3 times 3 times 3. That's what it would be. Okay, now I have this new expression, log 9, 3. So what's the base? 9. The exponent is the thing we figure out results in a 3. Why do we have what? Oh, I solved this to be 3 first. And what does this equal then? A half. Yep, because the square root of 9 is 3, and when we square root, it's the same exponent, a half, right? Okay. Number 2, a log equation. So I'm going to go log 3 of, I'm going to tie things back together with the rules. So there has been 2 separate with an add. So how were they put together? Multiplied. So these 2 things were multiplied, and that's why I split them apart with adding. Okay, this is in log form. I'm going to change to exponential form now. Can you change the format? So base exponent equals result. Can you change that for me? So you should have a 3 to the 1 equals, does that make sense form-wise? You see them all? Okay, so 3, can you FOIL this? What do you algebraically do when you get to these points? You subtract the 3 because the purpose is to get a 0. So as soon as you see 2 variable types, you zero it out, right? Now I'm going to try to simple trinomial 5 times 1. That will work. And you're still not done.
Because you gotta figure out which one works and which doesn't.
Well, they might both work. I don't know, but
In this case, it does.
okay. So how do I know if it works or not?
Plug in the
You plug it in, and it has to be positive. So 5 minus 4, that's good. 5 minus 2, that's good. 1 subtract 4, no. I can't have a negative result.
Are we done now?
Wait, what?
Your number, when you plug it in, can't make,
You said.
it can't make that position be negative. Or 0, actually. So it has to be positive. So when I plugged an x value of 1, 1 subtract 4 made a negative 3, so I can't have that work. Okay, simplify. Okay, we have to tie this all together. Ready? What do you do when something is split with subtraction? Divide. So I have this divided by that. There's two things dividing. What do you do with the 1/2 in the front? Becomes the exponent. So there's the rules. Coefficients can go to the exponent. Subtraction was that they tied together with division. A is the base, yes. Yep, there's nothing I'm going to do with it, but it's the base. Okay, now, like you're not going to be able to mathematically figure this out if that's what you're thinking. What is 36 to the 1/2? 6. Because are we thinking square root?
Yeah.
And what is 6 divided by 2? It's just the rules. You have to get those rules. You know what? They are on your formula sheet here. Did you know that in this corner? I don't think I gave you these formulas when we did the test because at that point you basically just need to almost have them memorized because you use them so much. But they are there in the corner of your formula sheet.
I can't see that again.
Like they're in this corner of your formula sheet right here.
Oh,
Yeah,
yeah.
should be. Okay, number 4. Solve. What strategy would we use here?
Where's the thing to the exponent to the front?
Move the exponent to the front? Not, I don't want to do that on this one. I can actually completely solve this without a calculator. Why? Same base. I can write them both with a base of what? 5. That and that, I can use a 5 to the something to make both of them. You see my work right now? I left the exponents there. I haven't touched those yet. Okay, 125 can get replaced with 5 cubed. Okay, so I just replaced 125. I replaced it with 5 cubed. 1/5, what can you replace that with? -1. Nice. Now, what do you do when you have exponents to exponents? Multiply. So 5 to the 9x plus 12. What do I do at this point? If the bottom bases are the same, you just kind of drop them off. And then you just conclude, if the bases are the same, now my exponents better match. Okay, isolate, get x alone here. So I'm going to minus 9x. Okay, you can reduce it to -6/5. You could have wrote me a decimal. You could have left it like that. I don't care. All 3 would be good. Okay, this one, you are not going to write that with the same base. So, what are we going to do here? we're going to, yeah, but we're going to move exponents, but to do that, I have to apply the log rules. So we're going to log both sides. Okay, ready? How do you separate these? This is 2 times a 7 to the x. So what do I do with the times? How do you split a times? When things are tied with timesing, you add log 2, and then the log 7, they're going to be added. What can I also do with the exponent? Move it to the front. Do you see my rules? The times I split with an add, and the exponent I moved in front of the 7 part.
So you wouldn't get the same result if you write down log 14?
No, because the x is only on the 7, and then the 2 is like the bed mass after, right? Okay, what does the other side look like? There's no multiplying or dividing, so now exponent into the front. What is my mistake? I made an error. There's a mistake. I made a very common mistake on purpose because everybody seems to do it.
X.
I need brackets because it's the whole exponent in front of that. I don't want just the 3 in front of that. I want the whole exponent in front of it, which causes a what? A distribution. Okay, what do we do now? X stuff one way, non-X stuff one way, so I'm going to do this. I'm going to move that direction, and you could have done the opposite direction of me, that would have been fine. So log 2 plus 3 log 3. We're almost there. Now I need to take the x out. Okay, what are we typing into our calculator? Log 2 plus 3 log 3 divided by okay, everyone remembers how to type this in? Does anybody already have an answer that wants to say theirs matches mine?
Yes.